All right, so this is the next episode in which we are going to do the circular linked list. So the first thing that we're going to do is initialize and then creation of the node. So creation of the node is pretty much exactly the same in every single one. Then we're going to define the circular linked list. Pretty damn straight. Okay. So we have certain specified steps for each of these simple things. We're going to do like the basic operations on it: insert, delete, search, and traverse, right? So the insert operation basically includes of simple steps like creation of the new node with the given data, and then we will check like um, if the list is empty, then the pointer is set to the next node itself and update the head to the new node. And if it's not empty, then find the last node which is pointing to the head. Then the fourth step is set the next pointer to the new node and the next pointer of the last node to the new node and update the head of the list to pointer new node. This is what the circular linked list insert operation at the beginning sounds like. It sounds a bit complex, but it's not that much complex. Perfect, fine. Okay, so now we're gonna do a while loop. It's not gonna take a long time. All right, so we're gonna do like the else part up here, in which we'll just put on the last node dot next and the self head new node and inserted the data at the beginning. This is the print statement. Okay, that was a long one. Okay, so I think self dot head is equal to new node. At the beginning. Okay, then define insert at the end. So at the end, basically it includes of I guess one, two, three. Okay, five simple steps. Five simple steps. So the first step is you basically create a node with a given data. Simply, you create a node with a given data, and then you start doing the checking conditions. Like you check if the list is empty. If it is empty, then of set the next pointer of the new node to itself and update the head to the new node, right? And if it's not, then what you do is find the last node pointing to head. The last node is basically the node pointing to the head, right? And then set the next pointer to the of the last node to the new node. And once you're done with that, set the next pointer of the new node to the head. Sounds a little complicated, right? But it's done. All right, now it's delete. So in delete, we're gonna do the easier things. Checking whether the list is empty or not, and if node is to be deleted is in the head, there is only one node, update the head to none. Simple. If there are multiple nodes and the node is to be deleted is the head, find the last node, update the head to the next node and update the last node's next pointer to the new head. And if the node to be deleted is not head, traverse to find the node, update the next pointer of the previous node to skip the node to be deleted. Alright, I'm telling you over and over again, dry run is your way. Dry run is your way to learn these things actually. I'll mumble up here for hours and hours a day, every single day. Still, you will genuinely have some kind of confusions every single day until you sit down and actually dedicate an hour of dry run. Dry run is the way. I'm telling you, these videos might go binge watch for you, but genuinely, if you sit down and actually watch these videos twice, three times, and then you start to do dry run two times, and then you start to code, you'll actually understand the entire concept perfectly, precisely. I'm guaranteeing you that. All right, then deleted the key element. So now we have the search operation. Search operation is obviously no, not yet. Okay, while current dot is not equals to self dot head, we'll check if okay, we don't check, we'll just simply uh, give previous is equal to current, current is equal to previous dot next, and if the current dot data is key, then previous dot next is equal to current dot next, and then we'll simply say that the data is deleted, the key is deleted. Right, and if all of these conditions are nonsense, then the key is not found in the linked list. Okay, now we have search operations, easiest things. All you have to do is start from the head node, traverse to the entire list, compare each nodes with the search key. If the node with the search key is found, return it. If it does not, then just say none. That's it. There's nothing complicated in the search. Search is pretty much the easiest ones. Dot head, then break. Self dot head, then break, and then once go out of it and return none. That's it. Great. And then we're going to do the traverse. So traverse forward backward is nonsense because it is circular. In circular, you don't have forwards backwards. You just have a traverse. That's it. So traverse is simply going to be start from the head node, traverse the list, accessing each node's data, continue while reaching back to the head node. So we're gonna do the entire circular. Oh, I have low charging. That's great. Okay. Current is equal to current dot next, and then we're gonna say if current equals to self dot head, then break and print head, because at the end of this entire traverse, the end element, the final node, has to be head, right? Okay, now let's just run this program and see how does this work. I just set up my charging. All we'll write the end final stuff before executing. We're gonna create the object first, which I'll call the CL. And CLL is dot insert at beginning. Just simply say 10, insert at the end. Something is wrong, I think. Why? Oh, that's why. Got it. I'm putting equals to instead of I'm putting dot equals to instead of putting dots. I'm trying to create like object equals to a function. That sounds nonsense. Dot delete node. Delete, I'm gonna do like maybe 10, 20, 30, 40. What shall I delete? Maybe 30. And then traverse the entire linked list. Okay, let's execute the program. And that's perfectly fine. So as you can see, insertion is done, deletion is done, traverse, every single thing is done pretty perfectly. So see you in the next with some new awesome data structures and algorithms. Till then, keep watching Code with Akya.